Finally, we're going to use these inverse matrices to solve systems of equations. The first thing I'm going to do when solving a system with inverse matrices is I'm going to write a matrix equation. Okay? The matrix equation is going to look like this. I'm going to start with the coefficients. Times the variables equals the solutions. Like that. And certainly this works. If you were to multiply these, you would take this row times this column, so you get 3x negative 2y. That's the first equation. You get 4x 5y. That's the second equation. So this is perfectly valid to break it down like this in a matrix. Okay. Now you're going to move the coefficient matrix by multiplying by its inverse. Okay. Let me show you a similar example, not matrix related at all, that tells you why this is working the way it's going to work. Say I gave you the equation 4x equals 12, and I asked you to solve that. Probably everybody in here would tell me, watching this would say, divide by 4. Well, you could also solve this by multiplying by 1/4. Multiplying by 1/4 is the same as dividing by 4, and more importantly, 1/4 is the inverse of 4. Okay, right? This 1/4 cancels out this 4 and leaves the x all by itself. That's the exact same idea as I'm going to use over here. Okay, if I multiply like this, okay, so I'm going to write out more than I normally would just so you can see it this first time. If I take this matrix, my coefficients, but I take its inverse, I'm going to multiply its inverse over here as well. Okay, so what happens there? By multiplying both sides by the inverse, whatever I do to one side, I do to the other side, so we're all good there. By multiplying this times its inverse, these cancel out. And what's left is just the variables, x, y. Okay, perfect. Last step, I'll write it up like this. We're not going to do this pencil and paper by hand. I'm going to say use calculator to solve. Okay, so how do I use the calculator to solve? Well, I need to type in these two matrices into the calculator. Okay, so I'm going to edit. This needs to be a 2 by 2 for this one. 3, negative 2, 4, 5. And I'm going to edit matrix B to be a 2 by 1, and it's 9, 2. And I get out of that, I quit. Now I want to do this one's inverse times this one. So I want matrix A's inverse times matrix B. That's where I typed them in, A and B. Okay, so I don't actually find the inverse. The calculator is going to find the inverse, and then it's going to multiply that inverse times B. Much faster than I could do it. Let's see if we can change those into fractions. There we go. That's about as awful looking as those answers could be. We get 49/23 and -30/23. Okay, so that's the x, that's the y. That's my solution. If I want to write it as an ordered pair, 49/23, comma, -30/23. That's it. All right, another example. I begin by writing the matrix equation. The matrix equation is 2, 5, 5, -3 times x, y equals 0, 31. So therefore x, y is equal to, I'm going to have this 2 by 2 matrix, inverse of it, times the 0, 31. All right, that's going to be calculator work now. So I'm going to type all this in. Oops. All right, let's try again. Matrix A inverse times matrix B 5, -2. So 0.5, -2. One more problem. I would say you could probably try this one on your own if you're getting the hang of it. See if you can do it. So pause the video, and then when you're ready, you can check your solution by watching the rest of the video. I begin with the matrix equation. Okay, and I solve for the x, y by taking the inverse of the coefficients times the 3, -2. And we're going to use calculator now to solve this. So I'm going to edit matrix A to be the coefficients. Edit matrix B to be the solutions. Take A inverse times B, and there's our answer, -3, 5. Okay, that's solving systems with inverse matrices. It works with 3 by 3 systems as well. The bigger 3 by 3 systems that take a long time to solve with elimination, same way. It's always this way, right here. It is inverse of coefficients times the equation's solutions. That's it. It's 2 matrices to type in the calculator, and you type in the A inverse times B every time, and it will generally every time work. Maybe in class we'll talk about when it doesn't work, but most of the time it's going to work just fine.